Assalamualaikum and very good morning to all. So now we are in the third chapter of instrumental analysis subject, and this time we are going to learn the third principle of spectroscopy, i.e. the atomic absorption spectroscopy. The abbreviation is AAS. Okay, so what is the biggest difference from what you learn in UV visible spectroscopy, fluorescence spectroscopy, and phosphorescence spectroscopy? The biggest difference between them and AAS is the keyword atomic. Okay, no more molecular chemical species, no more. Okay, whatever been subjected to AAS analysis, every chemical compound will be atomized into element. Okay, single element lah. Okay, if let's say you want to analyze metal mercury, it will be with mercury element, because when it is atomized, it need very high temperature. When it need high temperature, means that this is not suitable for organic molecules anymore. Therefore, AAS is suitable for inorganic analytes. Okay. What are inorganic analytes? Okay, inorganic analytes which are not comprising of C, H, O, N, and S. Okay, let us see what will be available for analysis in AAS. Okay, basically most of elements inside periodic tables can be analyzed with AAS. Most of it will be metals and can be metalloids as well. Okay, non-metals can be analyzed but with certain modification. Okay, AAS is very good for metals. Metalloid, we need certain modification in terms of the instrument. Okay, at the end of this chapter, you will learn about flame AAS, graphite furnace AAS, coal vapor AAS, hydride generation AAS. Why you need to learn all these four? Because respective instrument shown here is suitable for elements according to their chemical properties. Okay, flame AAS is using flame as atomizer. Remember, we want to atomize every chemical that is injected into the single element, while graphite furnace is using a very hot electrodeless, flameless furnace inside it. Coal vapor, in the other hand, is using chemical reaction to atomize. The same thing with hydride generation. We are mixing two reagents with analyte in order to atomize it. That's what it is called coal vapor, because there's no high temperature as compared to flame or graphite furnace. So this is the instrument of atomic absorption spectroscopy. To be specific, this is flame AAS. Okay, this flame AAS is available in Department of Chemistry. Our Department of Chemistry, we have two of them readily available to be used by PSM students, postgrads, as well as outside samples sent to UTM. The most significant features for flame AAS is that we have a chamber of flame over here. This is literally flame, just like what we use in cooking, but at higher temperature given by the source of gas that is different from cooking. Okay, so let us recap the fundamental of spectroscopy. The same thing with what we learned so far in UV visible, fluorescence, and also phosphorescence. Okay, it consists of absorption. If you are doing AAS stands for atomic absorption spectroscopy, means that absorption is analyzed. Okay, if you are doing AES, means that AES, atomic emission spectroscopy, you are analyzing the emitted light. Okay, why absorption? Why emission? Why can they absorb and emit? Because of the changing transition of electron when it is bombarded by radiation. So in AAS, the radiation usually is in UV range. Again, UV range between 190 to 390 nanometer, kan? And we also have visible. Okay, so it can excite with the bombardment of the radiation. Okay, be it from halogen lamp, a tungsten lamp, or even holocated lamp that is more sophisticated. Okay, high energy, very high energy to excite from ground state to excited state. Okay, so in atomic spectroscopy, okay, we have optical spectroscopy, whereby the all those collection of collection of transmitted or absorb radiation is using optical, while another one is mass spectrometry that will be learned at the end of the subject. So in optical spectroscopy, we have AAS and AES, while in MS we have ICP-MS. Okay, we will learn later. So method based on atomic spectroscopy, we have AAS, AES. So the difference is emission and absorption. But for this chapter 3, we will learn this. This one in chapter 4 and so on. Atomic absorption spectroscopy measure the absorption of radiation by atoms in gaseous state. That is the biggest difference between UV and AAS. Okay, versus UV. Visible. Okay, so this is the schematic diagram of, let us see, on the AAS only. Okay, so you have lamp to bombard radiation towards the sample. Okay, you can eat. Okay, it can bombard the radiation into the sample. But in this photo, where is the sample? Okay, it's easy. The sample is actually under the flame. It is been siphoned inside the flame so that it will be atomized. Okay, once it is atomized, okay, it will absorb the radiation coming from here. So whatever been absorbed, you will be having, it will be filtered by monochromator and then go to detector. So in this schematic diagram, another biggest difference between UV visible and AAS is that the monochromator is situated after the sample and flame, whereas in UV visible, it is before the sample cuvette. Okay, so that is the biggest difference, because this lamp is dedicated for one element only. Okay, for example, if let's say you want to analyze PB2+, means that you are using holocathode lamp of PB only. Okay, therefore, it is okay for the monochromator to be after the sample because it is already giving the radiation at wavelength dedicated for PB only. Okay, so let us see the difference. That's where I said sample is located after the monochromator, while here sample is located before the monochromator. Thank you. Okay. Okay, let us see a video of flame AAS for you to understand more. Okay, let us see.
This This animation of a flame spectrophotometer will provide an idea of how the machine works. The analyte is taken into the nebulizer where it is vaporized and conditioned to provide the best sample for the flame. The radiation source sends light through the flame and into the monochromator. In the monochromator, the beam encounters a series of mirrors that separate the beam from any background light and noise that is not necessary for analysis. This filtered beam finally hits the detector, which relays the data to the analysis software. This is the gas that feeds the flame. These are the lamps that provide the source of radiation. The lamp is specific to the analyte. The analyte is taken into the flame by this capillary tube. Data collection is performed by software installed on a computer. This demonstration will use a sample of copper. First, start by cleaning the sample capillary with a chem wipe. Then, insert it back into the sample to be aerosolized, mixed with gases, and released into the flame. The flame turns a green color that is distinctive of copper.
Look at the color of the flame,
Then siphoned off.
The color is dedicated for, it is actually very specific for each element.
The data is then sent to the computer.
The blue just now, I think, is copper. Okay. So that's how AAS looks like. In Department of Chemistry, we have AAS in level 4 C19 and ground level of C10. Okay, operated by E.T. Azani. Okay, we will look into the instrumentation of AAS flame AAS spectrophotometer in the next video, but I just want to show you the overview of the instrument. Okay, so this is this is the flame chamber. Okay, there is actually a gas down here. Okay, the gas is different from what mostly it is different from what we use in daily life. We can even use acetylene gas and so on, so that it can give you a flame that is high enough for atomization. Okay, the temperature is usually more than 1000 degrees C. Okay, and then we have the furnace, we have the auto sampler, and then we have the lamps. Okay, the radiation source, you can either use HCl or EDL. Okay, electrodeless discharge lamp. Then we have oh, this is the gas, sorry. So this is actually the gas, the gas. Okay, and then we have a computer over here. So we will see one by one for each of flame AAS in the next video.